Hello everyone. This question is the from work for energy. We have to need the this is the given point, a body of mass m starting from rest. A body whose mass m starting from rest and from the origin moves along the plus x axis with a constant power p. Calculate the relation between velocity and time, relation between distance and time, relation between velocity and distance. So we have to calculate the three numbers. First one is the velocity and time. Second one is the relation between distance and time. And third one is the velocity and distance. So we have to calculate these three quantity. But in these questions, the given point is the mass m is the given. This is the from the rest. So we can say mass m is the given. Mass m is the given and power p is the given. Mass m and power p is the given information, and this is the from rest and from origin along the x-axis. Okay, so we have to need these three relations. So we know that power p equals to dw by dt. Rate of a change of work is known as the power. We know that work equals to work w equals to work w equals to f dot d, f dot d, or we can say f dot r vector. F is the force and r is the displacement. So dot product of displacement is equals to work. If we can say force is the constant, if force is the constant. Okay, so we can be put in place of a work, which will be equal to d by dt of f vector dot r vector. Okay, force the constant, so we can pick out the force and rate of a change of r is the variable. So we can say f dot dr by dt. Dr by dt, rate of a change of displacement, is known as the velocity. This is the velocity, this is the velocity. So power p equals to f vector dot velocity vector. Force and velocity, dot product of force and velocity, which will be equal to power. If force is the constant, then we can say power p equal to f dot v, f dot v. Okay, but in these questions, this is the from rest and from the origin moves along the x-axis, moves along the x-axis. Let us suppose plus moves along the plus x-axis. So we can say force and velocity, those will be parallel, not anti-parallel. So those will be parallel. We are assuming that is the force and velocity will be parallel. Okay, so we can say a dot b equal to mod a mod b cos of a theta, where theta is the angle between f and v. Implies that we can say mod v mod f mod v into cos of a 0, which will be equal to f v into cos of a 0. So we can say power p equal to f into v. Power p equal to f into v. We have to calculate these three relations. So how you calculate these three relations? Power p equal to that number. Power p equals to, we can say f times v, f into f. F is the force can be written as the mass into accelerations, that is the v, and acceleration can be written as the rate of a change of velocity. So we can say m into dv by dt times v. Okay, so p is the constant, mass is the constant, implies that v is the variable. So we can say this number dt. So in differential form, if dt and dv are the given, so we can use in variable separable form. So dt can be shifted left hand side, imply that we can say p by m into dt, which will be equal to v into dv. V into dv, we can integrate both sides. P and m is the constant. Okay, v and dv, v is the variable. So we can say at time t equal to 0, so velocity v equal to 0. At time t equal to t, velocity v equal to v, implies that p by m into dt. Integration dt, which will be equals to t plus c. T plus c, upper limit is the t, integration of dt, which will be t plus c, means upper limit t and lower limit 0. So t plus c minus t plus 0 plus c, which will be equals to value that number equal to t. Okay. So this is the t number equal to v into dv. V into dv is the v square by 2. So v square by 2 plus c, upper limit, lower limit, then v square by 2 plus c. Okay. So that number which will be equal to, so v equals to, we are finding the value of a v. P by m, this is the 2 number. So shifted 2 number left hand side, imply that we can say v equals to p by 2m, sorry, 2p by m into t square root. That number is the square root. Okay. So this is the velocity in function of a time. Imply that velocity is proportional to the root of a t, because power p and a plus weight mass m is the constant. We can say this whole number is the constant. So velocity is proportional to the square root of a time. Okay. So first relation can be find out, will be calculated velocity and time. Relation between velocity and time, which will be equals to v proportional to root of a t. Root of a t. This is the velocity and this is the time. Okay. Now we are trying to find out the second point. Second point, the relation between distance and time. Second point, the relation between distance and time. So for distance and time, what will be number will be given? We know that v equals to root of 2p by m into root of t. P and m is the constant, so whole this number is the constant. So v equal to constant into t. Okay. V is the velocity. Velocity can be written as the rate of a change of displacement. Rate of a change of displacement. So dr by dt. Dr by dt, yeah, dx by dt equals to, this number is the 2p by m into root of t. Okay. This dt will be shifted right hand side because we have to need the value x in function of a time. So we can say dx equals to root 2p by m into root of a t and into dt. So we can integrate both sides. Integrating both sides, this number is the constant. So time t equal to 0, then displacement x equals to 0. Time t equal to t, displacement x equal to t. So 2p by m into that number. How you can say just after time t equal to 0, then displacement equal to 0? Because in this question they given that particle move from rest and move from origin along the x-axis. So this situation is the given. This is the x-axis, let us suppose x-axis plus x-axis. So time t equal to 0, initially r equal to 0, x equal to 0 and velocity equal to 0. So time t equal to 0, velocity equal to 0. At general time t, velocity equal to v. So we can say time t equal to 0, velocity equal to 0. Time t equal to 0, displacement x equals to 0. Because this particle is moves from the origin along the plus x axis. Rest and velocity, rest and origin. So x equals to root 2p by m into, this is the number root of a t. Root of a t equal to t square by 2. This number is the t square by 2. So t or 1 by 2 plus 1 divided by 1 by 2 plus 1. 1 by 2 plus 1, which will be equal to 3 by 2. T or 3 by 2, 3 by 2. So we can say 2 by 3. So that number equal to t ki power just occur 3 by 2. So this number is the 2 by 3. 2 by 3, because this number is the 3 by 2. So this 2 goes into the numerator because this number is in denominator. Imply that we can say x equals to that number. So x equals to 2 by 3 into that number into time t की power 3 by 2. Okay. So x is proportional to the t की power 3 by 2. So this is the displacement and time, relation between displacement, distance and time. So second number is the proved, displacement and time. And we have to prove the velocity and displacement, velocity and distance. Okay, velocity and distance. So third point is this. Let us suppose third point, we can say x equals to 2 by 3 root of 2p by m into t raised to 3 by 2, t raised to 3 by 2. So we can say here just after this is the distance and this is the time. So we are trying to find out the time relation in the time relation in the velocity, because distance is the given, distance is the no problem. This is the given point, this is the distance and this is the velocity. So and time t की power 3 by 2, this is the t की power 3 by 2, imply that t की power 3 by 2 can be written here. So x equals to 2 by 3 root of 2p by m into, this is the velocity is proportional to the root of t. So root of t to power 3, because t to power, this number is the t to power 1 by 3 power 3, so t raised to 3 by 2. So we can say this is the velocity, x equals to 2 by 3 into root of 2p by m into v raised to 3, v raised to 3. So we can say x proportional to the v raised to 3. So this is the third point, velocity and distance and velocity. So distance and velocity, x proportional to v raised to 3, and second distance and time. So we can say distance x proportional to t raised to 3 by 2, and first one is the v proportional to the root of t.